Okay, here in section 4, it's basically the same thing as section 3. They do introduce some identities here, although we really don't use those right now, so I'm going to go through these very quickly. You can see reciprocal identities. We've already talked about reciprocals a little bit. As far as identities are concerned, sine equals 1 over cosecant, cosine equals 1 over secant, tangent equals 1 over cotangent. So I assume it translates that cosecant equals 1 over sine, secant equals 1 over cosine, cotangent equals 1 over tangent. Pythagorean identities, again, we really aren't going to use these yet. I'm going to go through them very quickly here. We'll see a lot of these later. Sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared, and 1 plus cotangent squared equals secant squared. And finally, our quotient identities, tangent equals sine over cosine, and cotangent equals cosine over sine. That's something for later. I'm not sure why they've inserted here at this point in time in our textbook, but we'll gloss over theirs very, very quickly. Just a couple of quick examples here to get us through, very similar to our work in section 1.3. Number 1 says to find each functional value. Notice this time we're just finding one function instead of all 6. This says to find cosine, given that secant equals 5/3. Well, I hope we've all picked up from our identity work or our trig functions that secant is reciprocal of cosine. So if secant is 5/3, then cosine is simply 3/5. It's reciprocal, so we just flip that fraction over, and that's all there is to it. Oh, let's see if we have yet another one of those. We do. Sine, we're going to find sine given that cosecant equals negative square root of 12 over 2. Well, the first thing I'm going to do before I even bother to find the sine is to simplify this radical. This radical should always be in simplest form. Showing that two different ways. 12 is 4 times 3. Square root of 4 is a perfect square, so it's 2 square root of 3. Or, how I like to do it, the prime factors of 12. 12 is 2 times 6. 6 is 2 times 3. So now I have 2 times 2, which is 2 squared, or a perfect square here, so it's 2 square root of 3. So we have negative 2 square root of 3 over 2, or if I simplify that one more step, the 2's cancel, and I wind up with negative square root of 3 over 1, or just negative square root of 3. I'm going to put it over 1 just for visual effect right now, because if we have cosecant, sine is reciprocal of that, so sine is going to be the reciprocal of negative square root of 3 over 1, or 1 over negative square root of 3. We have to rationalize the denominator. So sine is going to be negative square root of 3 over 3. So we reviewed some quick algebra there along with finding our sine. Moving on here real quickly, above this chart I'm going to write at least our first 3 functions, sine being y over r, cosine being x over r, and tangent being y over x. In our table here, we want to find out what the sign, positive or negative, is for each of our functions in each of the quadrants. So going through here, here's our coordinate plane. Reviewing our quadrants, quadrant 1, 2, 3, and 4. In quadrant 1, we're over positive on the x, we're up positive on the y. X, y, and r are all going to be positive, so sine, cosine, tangent, cosecant, secant, and cotangent will all be positive. Now, as we move to quadrant number 2, let's say I put a terminal side in quadrant number 2. If we come over in quadrant 2, we are now negative here on the x-axis, so anything that has an x in it is going to be negative. We're still up positive on the y, so the y's will stay positive. So sine is y over r. We know r is always positive. Y is positive in quadrant number 2, so sine is still positive in quadrant number 2. Cosine is x over r. Well, we're over negative on the x-axis. R is positive, so cosine is negative in quadrant 2. Tangent, positive y over negative x. It will also be negative. Then our reciprocals, sine and cosecant, will both be positive. Cosine and secant, negative. Cotangent and tangent, negative. As we move to quadrant 3, let's just change colors here. Quadrant 3, we're over negative on the x, but we're also down negative on the y, so anything that has an x or a y in it by themselves is going to be negative. Sine of being y over r, sine will be negative. Cosine x over r, cosine will also be negative. Tangent has both a y and an x. Negative y over a negative x is a positive. If sine is positive or negative, then cosecant is also negative. If cosine is negative, secant is negative, and if cotangent is positive, then cotangent is also positive. And then finally in quadrant 4, if I go over here to quadrant 4, we're back to being positive on the x, but we're down negative on the y. Y's will be negative, so negative, positive for cosine, negative for tangent, negative for cosecant, positive for cosecant, and negative for cotangent. So there's our signs for each of our trig functions in our quadrant based on the x, y, and r, those definitions that we should have pretty well ingrained right now. Number 2 says to determine our signs of our 6 trig functions. Now we could regraph that table every time we had a question like this, or just a little common sense. If I sketch that angle, 87 degrees is going to be here in quadrant number 1. Well, we should know that in quadrant number 1 that all 6 trig functions are positive in quadrant number 1 because x, y are both positive in quadrant number 1, and we know r is always positive, so all 3 of our values are positive, which means that our functions are going to be positive. Letter B, 300 degrees, measuring counterclockwise, 300 degrees is going to put us in quadrant number 4. 180, 270, 300. Okay, so we're in quadrant 4. In quadrant number 4, our y is negative. Our functions that contain y values are sine, tangent, cotangent, and cosecant. Since they contain a y, they'll all be negative, which means cosine and secant are positive. Okay, so just based on what quadrant we're in. One more time, negative 200 degrees. Sketching that, hopefully we know negative angles are measured in a clockwise direction. There's 90, 180, 200. 200 is going to put us in quadrant number 2. Quadrant number 2, x is negative. So anything that contains an x, which will be cosine, secant, tangent, and cotangent, will be negative, which means that sine and cosecant will be positive. Okay, question number 3 asks essentially the same thing, but instead of asking for degree measures, we're going to be talking about quadrants. So we're going to identify the quadrants. Sine. Sine is positive wherever y is positive. Well, y is positive in quadrant number 1 and quadrant number 2. Tangent is going to be negative wherever x or y are negative. So tangent is negative in quadrant number 2 because x is negative there. It's not negative in quadrant 3 because both x and y are negative, but it is negative in quadrant number 4 because just the y is negative. So now, making both conditions at the same time, you can see they both have quadrant 2, so they overlap, or quadrant 2 meets both conditions at the same time. Letter B is a little bit easier. Cosine is less than 0, which is negative. Cosine is negative in quadrants 2 and 3. Secant is a reciprocal, so it's also negative in quadrants 2 and 3. So in this case, we have 2 quadrants as our answer, 2 and 3. Interval notation or range notation. 2 different ways to write this. And this is just something that we'll pick up as we go, but we do eventually need to know this. Sine has a value for our y. So y is going to be between -1 and +1. Okay, so for our sine function, our values lie between -1 and +1. We'll talk about this more in our graphing concept, Another way of writing that, y is less than or equal to the absolute value of negative 1. Okay, those are our two ways, but essentially sine can't have a value larger than 1. It can't have a value smaller than negative 1. It all follows those decimal values between 0 and 1 and 0 and negative 1. Tangent has a value from 0 to infinity, so from negative infinity to positive infinity is our range for tangent. Oops, didn't want to do that, so let's start over again. For our interval notation, it's just simply all real numbers. And then cosecant, reciprocal of sine and cosine, so our range here, it goes y is greater than or equal to negative 1. Oops, I'll try that again. Let me just erase that. That's bad. So y is less than or equal to negative 1, or y is greater than or equal to a positive 1. In other words, for secant and secant, or cosecant, our values are 1 or above, or negative 1 and below. Nothing between negative 1 and positive 1. And then here, the absolute value of y is greater than or equal to 1. Okay, so what that means for us is we just said that sine can't have a value larger than 1. So is the value in the range? It is not. So no, it is not. Sine cannot be 2.5. If you think about sine being y over r is the hypotenuse. The hypotenuse is always the longest side. So if I have my longest side here, my shorter side has to be smaller than 25. So we'll say 16 over 25. It's always going to be a fraction of being less than 1. Okay, so sine will never be more than 1 or less than negative 1. Using that same idea for these last couple here. Tangent equals 110.47. Tangent can be pretty much any number possible because it runs from negative infinity to positive infinity, so yes, this can happen. Secant of theta equals 0.6. Secant would be r over x. Hypotenuse, always the longest side, so I had 25 over any side that's going to be smaller than that. That was going to be larger than 1, so it can't be a decimal smaller than 1, so no, it's not possible there. Find all the functional values in quadrant 2 that sine is 2/3. Well, we know sine is y over r, so we know that y is 2 and r is 3. We can use that then to find x, so x squared plus 2 squared equals 3 squared, or x squared plus 4 equals 9, x squared equals 5, x equals plus or minus the square root of 5. So we're in quadrant 2. Quadrant 2 is where x is negative, so x is negative square root of 5. And now sine is going to be, we already have sine, I'll write it again as 2/3. Cosine is going to be negative square root of 5 over 3. Tangent is going to be 2 over negative square root of 5. We rationalize by multiplying by square root of 5, and tangent is negative 2 square root of 5 over 5. Cosecant is 3/2. Secant is reciprocal, negative square root of 5 over 3, so 3 over negative square root of 5, which simplifies negative 3 square root of 5 over 5. And cotangent, reciprocal here, negative square root of 5 over 2. There's our 6 trig functions for that information. Same idea here in number 6, A and B. A says to find sine and tangent given the sine is theta is greater than 0 and cosine is negative square root of 3 over 4. So here, cosine is x over r. I'm going to set up my x, y, and r over here. X is negative square root of 3, R is 4. Now we have this negative sign here. Notice that I assigned it to X because we've already established that R is always positive. Okay? That means the negative sign has to go with the X, so X is negative square root of 3. If we do our Pythagorean theorem, negative square root of 3 squared plus y squared equals 4 squared. Negative square root of 3 times the negative square root of 3 is just 3, plus y squared equals 16. Y squared equals 13, so y equals plus or minus the square root of 13. It says right here that sine is greater than 0, so sine is a positive square root of 13. And that should make our sine and our tangent pretty easy to come up with. Sine is y over r, square root of 13 over 4. Tangent is y over x. We have to rationalize, so we have negative square root of 39 over 3 for our tangent. And I believe this is our last problem here. Find sine and cosine given tangent is 4/3. Well, tangent is y over x. So I'll set my x, y, and r over here. Y is 4, x is 3. Hopefully we know our triangles, at least this triangle by now. R is 5. Will be a plus or minus 5, but we should know r is always positive. We have a 3, 4, 5 triangle. Sine then is y over r, 4/5. Cosine is x over r, which is 3/5. There's our functions. Oops, my bad. I need to go back here. We were in quadrant 3. In quadrant 3, both x and y were negative, so both of these are negative. Negative 4/5 and negative 3/5. So that'd be a great point to make here. Trig comes down a lot to the details, so pay attention to the details as we go through here and keep track of those operations. We have negative on each of those. And that concludes section 1.4.